Okay, great. So David, you want to start?
Yeah, right. I'll kick off, and thanks AnyLogic for hosting us and giving us the opportunity to share our work on simulation. And thanks for letting us be the first cab of the rank. There is a little bit of lagging going on and echoing. So can you guys take care of that first before I kick off? All right, I think the echoing has gone, has been resolved. So yeah, we'll kick off again. I think the echoing is gone. So yeah, thanks for hosting us and giving us the opportunity to share our work. We have been doing a lot of work in the realm of simulation at Domino's lately. And Chauvin here will present you a little bit more and unpack the technical solutions and methodology behind it. My name is David Federer. I will sort of give you a little bit of context and set the scene of who we are and what we have been doing and why we are needing simulation. So basically, we are Domino's Pizza Enterprises. We are in the business of serving hot and fresh pizza and delivering that to people's doorsteps. And if you don't want to get your pizza delivered, then you can also pick it up from one of our 3,000 stores across 10 markets in Europe, but also in the Asia Pacific. Actually, recently, Domino's acquired a couple of additional markets in the Asia Pacific region, including Singapore, Cambodia, and Malaysia. And because we have been growing so fast lately, we have been opening a lot of stores. And what you basically need to look out for when you open a store is the right location. You need to pick the right location where you can serve as many customers as you want, pizza lovers as you want. But also what is equally important is that you lay your store out in a most optimal way, right? So you want to really create an optimal store layout that enables you to sort of execute and make pizza in a very optimal way, so that you don't get in each other's way when you make the pizza. And so that's really important. So one of the things that we have been doing while keeping that in the back of our minds is simulation. So before we actually hit the physical store with changes or layouts, basically what we want to do is we want to have this sort of digital twin environment where we try out new concepts and new concepts and new store processes, as well as optimal layouts before we implement them. Next slide, please. So to that end, what we have done is we have basically chosen AnyLogic as a platform in which we can build those digital twin environments. And one of the things that we have been looking at is, next slide, basically to use the AnyLogic environment for store layout and store design, right? So every time we open a new store or we want to refurbish a store, basically this utopic dream is to basically simulate that first in a digital environment before we implement that in a physical environment. And so that is one of our use cases to start with. Then the second use case that we have been looking at is to use simulation to basically sort of optimize our staff rosters, right? So you can imagine that if you have a bad store design, that rostering of staff becomes an issue as well, and you're not basically accommodating your staff optimally to work in your stores. So staff rosters is important as well. And one of the third use case that will become really important, we have been working on that yet, is to enable the business to run what-if analyses. So what we want the business to be able to do is, if they want to try out a new concept in store, or they want to introduce a new product or a process change, then what we want to enable the business to do is basically run a what-if scenario. So what if I were to roll out this process or this product? What impact would that have on my store layout, and would I have to change my store layout to accommodate for those process changes? So that's really important. So without further ado, what I'll do is I'll hand over to Chauvin, who will unpack that a little bit more for you and show you how we have gone about implementing this.
Cool, great. So yeah, I'll be expanding a little bit more into how we set up our simulation, and also like some of the interesting insights that we've uncovered from this whole process since we started using AnyLogic. So when we start building our simulation for a given store, there are three main components that we focus on. So the first is, of course, the physical store layout. So that involves the dimensions and the shape of the floor space itself. So all the walls, the entrances and exits, and then also the dimensions, the shape, the placement of all of the store equipment. And so that all of that, from a store floor map needs to be translated into an AnyLogic representation. And then from there we can, proceed with running our simulation. And of course, the next important component of our simulation is all of the process flows. So this is essentially, the underlying logic that dictates how the agents will behave in the simulation environment. So what happens when an order comes in? What are the steps the in-store staff need to follow in order to complete that order? And then, of course, we have, just like in a real physical store, all of the data that would flow into that store, all of that equivalent data also flows into our, this virtual or this simulated store. And that includes, in particular, all of the order data, and then, of course, all the staffing data. In particular, with regards to staffing, we do have, different roles. So staff that specialize in different things. So there would be staff that are focused on, working on the make line, that is, preparing your product. And then there are other staff members who are focused on delivering the product. And then there are, some other staff members who are more so in a leadership role. And so when the orders come in, these agents or these staff members would behave, differently based on the priority of their roles to complete that order. So, given that, we started off with our simulation journey with some of the stores here in Australia, and slowly we're expanding across some of the markets that David mentioned earlier. But and so what happens is that, if you go into a Domino store, no matter where in the world, you're going to get a delicious pizza. But the steps taken to prepare that are slightly different depending on which part of the world you're in. So whenever we expand into a new market, we always have to kind of, in some way, start from scratch and try to understand, what the intricacies of that market. And so the first thing that we always do is we engage with the subject matter experts within the operations team. Figure out what sort of products they've got on their menu. What are the steps that are involved in preparing those products, and then kind of figure out how we can adjust our model to take that into account. We also spend a lot of time in the store itself. We go into the store, we observe staff members kind of going about their duties, preparing orders and delivering them, and we also engage with them to ask questions to clarify things relating to the model. And where we're not able to travel, we of course get access to video footage that we're able to analyze to see how things are done. And again, whether we're in store or whether we're looking at the video footage, we do a lot of time motion studies to figure out how the different steps, how long the different steps take. So like how long does it take to sauce a pizza, or how long does it take to load ingredients on that? How long does it take to cut and box the pizza? And depending on where you are in the world, that could take the timings could be very different. Another thing that we also look into, which I've just mentioned before, is that we have access to a lot of very detailed data, and so we go into the data to start with, and that already kind of gives us an indication of what sort of problems we might be looking at. So we dig really deep into all of the order data, all the staffing data, and that already gives us kind of a heads up in terms of what we should be looking at. And finally, we also engage a lot with the different construction and equipment specialists. And there is obviously within our pizza store, we have different pieces of equipment. So for example, we have the centerpiece of our store, which is the oven where the pizza is made. And that oven could be very different from store to store. And so we need to figure out, well, for a given store, which model they're using, what is the capacity of that, how many racks does it have, how many pizzas can a rack hold, what is the pizza to side ratio. All of these things help make our model very more accurate. So essentially, every time we go into a new market, we really have to engage with all of these different stakeholders, from the operations team to the construction team, the equipment specialists, the in-store staff, so that we can get a deeper understanding of that market, and then we incorporate that into our modeling process. And of course, the first step when we start the actual modeling is, of course, taking a floor plan from an actual store floor plan. If you're looking at an existing store, we take that floor plan and we convert it into an equivalent AnyLogic representation, as you can see on the right. What right now our main focus is on modeling for peak times and how we can improve store efficiency for peak times. So you might see that on the actual floor plan there is a lot more equipment than what you see in the simulation, and that's because right now we're focusing on simulating more of the critical workstations or critical equipment that is more important during peak times. Um, so yeah, on the right we have a typical Domino store, right, that you might have seen in your neighborhood. We have the entrance, and the customers walk in, and you've got your front counter, you've got your make line, you've got your oven, where items go in, and then once they come out, they're cut on the cut bench, placed on the hot rack, and then from there, the driver can take it and deliver to the customer. We also have other important things like cold room, where all the supplies are kept, or the dough station, where the dough is made, and then of course ice cream machine, sink, and so on. And so this is our typical Domino store, and with this whole simulation exercise, one of the things we do try to figure out is what sort of layout would work best for a given store, and how we can improve the efficiency of the store with respect to that. Um, and so, starting with this whole journey, one of the first questions that we got from the business was, what sort of floor space works best, right? So, what sort of dimensions, what sort of shape works best for us, right? And so we through simulation, what we found is that for us, square floor spaces work a lot better than these rectangular floor spaces. And you see here two floor plans for two different stores that are given. And on the left, we have a store which is kind of much more proportional, much more squarish in shape. And then on the right, we have a store which is much more rectangular. And what we found is that when we go about trying to redesign stores, a square floor space like the one on the left, it allows for way more design possibilities, but it also allows for more range of movement for the staff. So in this case, if you can see my cursor moving, the staff can move horizontally, they can move vertically, and they can also move diagonally in many cases. And so that helps reduce a lot of the foot traffic. And so it reduces the footsteps that they're required to move between one station and another, and that helps improve order times. On the right, there's this restricted movement, because you're only kind of moving horizontally, and there are of course design limitations because of the floor space itself. And what we saw that this, what we discovered through simulation, we've also seen that this kind of translates into metrics outside of that, which is that we found that a store with more rectangular floor space generally requires higher labor, because there's restricted movement, and you might need more staff members to get the same thing done. And we also saw that it might result in higher order times. So that also results in like lower customer satisfaction, as opposed to a more proportional floor space. So that's something that we started off with. We found that we want to work with going forward, as a business rule, we want to focus more on more proportional floor spaces, and also more compact floor spaces. And again, tying into that, the next step that I mentioned earlier is that we want to optimize the layout of the store itself. But at its core, what we want to do is we want to make sure that the staff members within the store are moving in a more streamlined way. So we want to reduce the number of footsteps that they take to complete an order, and at the same time, we also want to make sure that they don't get in each other's way when completing an order. So if you look at a layout, this on the left, that is a layout for an existing store that we have. And we have the typical store equipment. You got your oven, cut bench, make line, dough station, front counter, and so on. You've got your entrance and exit here at the front. And then we've got these arrows here. So the black arrow indicates the movement of the driver, and the orange arrows indicate the movement of the make line staff. So the make line staff, essentially the people who work on preparing your pizza or your sides. And so what we've seen is that obviously we see this intersection between their movements. And so what that means is that they're getting in each other's way. The drivers and the make line staff are getting in each other's way, and that is not ideal, because during peak times that makes a lot of difference. The other thing that we're seeing is these arrows are unnecessarily long. So if you're working the make line, you might need to go to the cold room to fetch ingredients, and then you have to go all the way across to the dough station, and then to the make line, and then into the oven, right? So that's a very long journey. And then similarly for the driver, right? They come over to the hot rack to pick up the items, and then they have to go all the way across and out. So that's again a very long journey. You're going in one direction, then the other direction to get out of the store. So that's not ideal. So with simulation, we tried figuring out what sort of what can we do to improve this. So we came up with this alternate layout here, which is essentially like a vertical flip of this of the layout on the left, where the make line, dough station have gone to the bottom, the front counter has gone to the top. And while it may not be obvious, the oven and cut bench here have changed orientation. So the entry of the oven is here. And so this has done two things, right? So this has now gotten rid of that intersection that we were having, where staff members were getting in each other's way. The other thing that we've done, that we've found through this is that we've of course reduced the distances or the steps that the drivers and make line staff have to take. So for drivers, it is a much shorter distance now to the exit, and then also for the make line staff, their footsteps between the cold room, dough station, make line, and oven is reduced significantly. So in that sense, now we're trying to figure out these sort of things for all our stores, and reduce the number of footsteps, but also reduce those intersections, prevent staff from getting each other's way, because all of these small things add up during peak times, and they make a huge difference. And slowly, what we're seeing is that the business is realizing the value of this, and now some of the designs that we've come up with through simulation are now being turned into actual stores. So this is a store this is a store in Australia that was damaged by the recent floods, and so this had to be rebuilt. And so that was a great opportunity for us to try out simulation, see what sort of layouts would work best for this particular floor space. And we came up with this. We came up with a bunch of different layouts, and then the construction team decided to go with the one on the left. And now that has been converted into an actual floor plan, and this store is now in the process of being built. So we've gone from the other way around now, from simulation to reality. And finally, another thing that David mentioned that we're looking at doing is we started off with trying to find the right type of floor space. Then we've tried to figure out what sort of layout would work best for that floor space, and now we are trying to figure out what sort of roster would work best for that particular layout. And so in this particular case, we did an experiment with one of our stores where we tried to see what would happen if we completely understaffed it or completely overstaffed it with huge order volumes coming in. What would happen? And so in this case, the layout is the same. It's just the staffing levels. The layout and the order volumes are the same. It's just the staffing levels are different. And so what we'll see on the left is a case where the store is understaffed, and the orders are coming in, and the staff are struggling to keep up with this, and the customers are piling up, and that's not good, because we're not able to service our customers within a reasonable amount of time. And then we see the opposite of that, where we pack the store with as many people as possible, right? And we see what will happen. And so again, this is that case that I mentioned earlier, where staff members are getting in each other's way, and that's not ideal either. And so this is again causing customers to pile up, and that's again not ideal, because we can't service our customers in a reasonable amount of time. And so if you think about this problem on a scale of being like completely understaffed to being completely overstaffed, there is a sweet spot somewhere. And through simulation, through AnyLogic simulation, we can figure out what sort of roster would work best for a given layout on a given shift. And just to kind of expand a little bit more on that, we'll look into this one particular case study. So essentially, when we start simulation for a new store, for a new or existing store, we start with a baseline layout, which is usually the existing layout, or a layout that has been proposed by the construction team in case of new stores. And then we try to come up with alternative layouts that could improve on that. So looking at this one particular store here, where this is a new store in Australia, and this is a layout that was proposed by the construction team. These arrows indicate some of the critical store equipment, and then we came up with two alternative layouts for that. So one layout is this one. Again, the arrows indicate how things are moved around, and then another layout here, which again, the arrows indicating how things have moved around. And when we come up with these alternative layouts, we try to present to our stakeholders, which may be the operations team, or the franchisee itself, or the construction team. We try to present to them all of the options and let them make their decision. So usually what we do is we try to compare the three designs in terms of efficiency. So in this plot on the right, what we're looking at is we're comparing these three layouts, the baseline being the original one proposed by the construction team, and then the two designs that we've come up with through simulation. What we're trying to compare is we want to show the efficiency of these layouts. So we've got this plot here where on the y-axis we have number of drivers, on the x-axis we have average delivery time, and so we see that that obvious trend that if you add more drivers, you're going to see a reduction in delivery time. But you reach a point where adding any additional drivers will not give you any additional benefit. And so we can find that sweet spot, like I said, and that sweet spot in this case lies somewhere between like 6 to 7 drivers for all of these layouts, and that's ideally where you want to be operating, right? And so what happens is that when we present these options, the decision maker in this case, in the franchisee or the operations team, they can decide which layout they want to go with, and then where they want to operate on this curve with respect to staffing. And especially with like with redesign, sometimes there's a huge cost involved with redesigning a store. And so this kind of gives the the decision maker in that case, an indication of what sort of savings are there, and so is the cost worth the savings? And so yeah, in this case, they can get an idea of all three designs and their efficiencies. Um, yeah, and finally, to kind of wrap up, through this whole journey with AnyLogic, what we've tried to do is, like I said, we started off with trying to find the right type of floor space, and then using that, we then try to figure out what sort of layout would work best for a new or existing floor space, and then finally we're looking into finding out what sort of rosters would work best for a given layout. And through all of this, we've also uncovered interesting design rules that we use going forward. So some of the things that I've already mentioned already, like we want compact square floor spaces. But one very interesting rule that we have uncovered is that the first one is that we want to make sure that our make line, oven, and cold room are in a triangular formation and very close to each other. And so what that does is that allows the make line staff to easily move from the make line to the oven or to the cold room, and that actually conflicts with some of our existing design paradigms. So we have this design paradigm in Domino's called the food theater, where if you've gone into a Domino's, what you'll see is your make line will be right in front. So the staff will be preparing your order right in front of you, right? They'll sauce it, they'll load the ingredients right in front of you. It'll be cut and boxed right in front of you. And this is done so that we kind of we let the customer see how their product is being made, and we get them engaged in this process. But that kind of conflicts with this rule that we have found, right? Which is that when we put the make line right in front, that means the oven will follow after that, and the cold room goes right to the back. So that breaks that triangular formation rule. So now we are in this interesting situation where we're trying to think of like how we can incorporate this learning, this interesting rule that we've discovered, while also keeping the customer engaged with the whole process of seeing their food being made. And so that's what we're looking at going forward. Yeah, I guess that's our presentation. Thanks for having us. Happy to take any questions now.
Yeah, so I've seen a couple of questions come in, so I'll read them out. So the first one here is from Sebastian Mazinski. So are you collecting real data to improve your algorithm? Something like a feedback? Maybe my question is too early. Yeah, so we are not collecting real-time data, but we are collecting daily data, sales data that is, as well as roster data, so when staff is scheduled. And what we have also been doing is time and motion studies, just to measure what each activity in store, the amount of time that it takes. So yeah, hopefully that answers your question there. Just for the sake of time, just moving on to the next question. So Abadia Ferra Gagusa is asking what our conceptual model was. So maybe, Shelvin, I'll pass that on to you.
I don't really understand what you mean by conceptual model here.
Yeah, I think what she means is sort of the framework that we used, potentially fitness functions and so on.
Oh, okay. I guess, yeah. So when we are redesigning, when we're looking at alternative designs, we try to use average order times as a guiding metric. So each layout is quantified. The quality of that is quantified in terms of how quickly, on average, across a number of days, it can get orders through to the customer. How quickly. So yeah, that's the metric that we go with.
Yeah, and Advance was asking, do you consider unified models for each of the different stores, or building a unique model for each store? So let me answer the question. It's actually a very good question. So what we have been doing is, and we still haven't scaled this up to a level where we should, but we are at the moment, we're building unique models for each store. And we'll keep it that way because each store in each region has different properties, different processes. So really what we want to go with is unique models for each store.
Yeah, so I'll just add a little bit onto that. Yeah, I think the differences come in when we go across markets. And so when we're within a market, I think the main thing that differs is really the layout, the physical store layout, whereas the underlying kind of logic remains similar. But yeah, as we move across markets, those we need to incorporate those specific market related constraints.
So we got a great question here from Yuri. So what is the ROI of implementing improved layout for one restaurant? So what we have seen, and we've only done a limited number of simulations, but what we see typically is a a 20% improvement in terms of efficiency. So that means staff. So what we see is that we can reduce the number of drivers by 20%, and these drivers can work in other parts of the store, right? So we free up drivers to actually be involved in our make process. So that's one. And in terms of delivery time, whilst we reduce the number of drivers, we actually improve our delivery time as well by 4.5%. So that comes down to about 50 seconds, which is also a major win. So really what I want to point out is one does not go at the expense of the other. You both reduce your the number of drivers that are involved, and these drivers can be employed somewhere else in store, as well as reducing your delivery time, which is good for the customer. Then just scrolling down a little bit more to another question, Ed and Ike is asking, what is the main difference for each store simulation by region?
So yeah, like I mentioned, it's different more in terms of how the product is made. So like how a pizza is made in Europe is very different to how it is made here. Like for example, in Europe they have that hand stretched dough, whereas here we use a lot of pre-made dough. So yeah, it's just like the difference mainly lies in terms of how the order items are prepared.
Yeah, and Shisheng is asking, a few seconds ago, you mentioned digital twinning. What are the aspects of digital twinning that Domino's is implementing? So basically, the aspects of digital twinning that we're trying to capture is to capture the actual representation of a digital representation of an actual store, so that we can actually try out different concepts or introduction of new processes of products in a sort of near real environment where we see what the impact is of implementing those processes. I think there's a few more there. So Louis is asking, where are you planning to move ahead from here? So yeah, what I think, and I think you'll see that in subsequent presentations as well of other presenters, is what the real challenge here is scaling, right? So what we are sort of looking at now is what steps do we need to take to scale? And those are questions that we still need to answer for ourselves. But I think scaling is paramount to actually make this work and make it being used by stakeholders. If there are no other questions, then that sort of wraps up our preso.
Okay, yeah. Thank you very much, David and Shelvin, for your presentation. Though, and thank you everyone for your questions. Though they were really interesting. So.